In this video, I will complete the PCB design in KiCad. Let's get right into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Okay, I've kind of moved on here to routing some of the power. This is to try to take care of a number of the more significant traces that are left, trying to reduce the noise I really have to look at here. So things like this, where I can't get to the ground reference pad on the capacitor, I actually have to move stuff over to make some room so I can actually get there. That's better. That should allow me to put a via here. Perfect. This one doesn't matter quite so much because this one is not power related, it's signal related. So from that perspective, should be able to come up here, put a via in here, and then complete this trace on the top. Now, on the other hand, this one is going to be part of the ground plane, so it really should be a more significant. These are all the resistors for the LEDs, and each one of them is isolated on an island, so it's going to be a bit of a nightmare to get those all hooked up right. I also have a challenge up here. Okay, let's do some checking here just to see how bad I am. I found something that doesn't make any sense to me. So I managed to set up, so let me give context here. Right here are the LEDs that show the value in the register. And one of the enable lines is labeled address bus to assert. Well, that certainly doesn't make sense because I shouldn't be asserting address bus 2 out onto the to control output to the LEDs of the register contents. So if I go back to the schematic editor, sure enough, these are the LEDs in question, and I managed to put address bus 2 assert in there, which is incorrect. That should be straight to ground for both of these. So made the change there in the schematic, and now I need to refresh. Update with changes made to schematic. So this now says ground, 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 ground. So this is no longer an address bus 2. But what I should be able to do now is eliminate all of this trace and the vias associated with it. That should then allow me to take at least this one, whoops, and go straight to ground. And then over here, this one's a little bit more challenging. And then that should allow me to take on the bottom this up to here. Now I still have a challenge getting these main bus bits. Not everything is wired up yet. And what a nightmare getting through here. I have 21 routes left to go. And I am still having a hell of a time with this. Alright. These two need to go over to here, but I have no place to create. Alright, I'm down to the last 8 signals that need to be routed. Now, 1, 2, 3, 4 of them come from down here. And need to be brought up here. 1, 2, 3, and something around here. Yeah, there's 4. So that's going to be a bit of a challenge. But I don't know where all the other ones are. Address bus and latch, ground references, and VCCs. So let's deal with the VCCs and the ground references first. Where is this? Ah, I saw it. Where was it? That's right in here. There's a VCC that needs to be routed somewhere up here. Actually, I should be able to bring this out here and then tie in there. Wrong. Trace width. Should be able to do the same thing with this one. Let's try grabbing it instead. Why are those coming up as thicker tracks? Alright, so that should take care of one unrouted track. Let's rerun it. Alright, one warning. Unconnected ends. That takes care of that. Now VCC. These last things, well, now I've just got the 4 control signals now. But these last items are just hell to get connected because I'm out of space big time. Alright, so these 4 have to go up to the right hand side of the board. And I have very little room to get them up there. For example, I've got ALUB assert that needs to come up here. I'm not going to be able to get anything through here. I'm not going to be able to get much through here. I might be able to get something drugged through here. Well, apparently I wasn't recording the last few traces, but this is it. This is the PCB. Oh, I guess it's not done. I guess I probably need to figure out how to do the copper fill. The filled zone up here. Ground. So I guess the question is, it's on there. The question is, how do I know it's filling? There's the filter. Okay. Okay, so anything that is not purple needs to have a via added to it. So if I've got, for example, I've got this area filled here, not filled, I need to come along and stick some vias in here. And the goal is to get as much of this filled as possible so I don't have these huge islands of wires that do not have ground around them. All right, let's rerun the design rules check again. It's not fantastic, but it's not totally horrible either. There are places in here that are just not gonna get great ground coverage, which is unfortunate, but I don't know that there's much that I can do about it without going to a four-layer panel, four-layer board. Okay, let's see what that did for me. I think I'm gonna let him cook this. I think I'm done. This was tough. I will tell you, this was tough. JLC needs some very specific option set when we export the Gerbers files. Fabrication outputs, Gerbers. And I'm looking on their website. Plot. And then after that, I need the drill files. They say Gerber, and I've got Gerber X2, so I'm assuming that's proper. And then generate drill file. So now these files here are what I would send to JLC. So let's create a folder. I'm going to rename this so it doesn't have the dash at the end. Drag and drop. Yeah, that looks like what I'm looking at. Let's see here. I'm going to start with 20. That way, if it's correct, I can get at least 20 registers out of it. I think I want to make them blue. It's still $19. Silkscreen white, 1 ounce copper, and I'm going to order the stencil at the same time. I am going to hand solder these, but if I find out that it's too ridiculously difficult to get it right, then I'm going to figure out how to do solder paste and get a hot gun so I can attempt it that way. So $4 engineering fee, $15 for the boards, $7 for the stencil, $26. Shipping is almost 50, so almost twice as much. It's what it costs. And then I've got to figure out how to source all of this as well. For sourcing, I can output a bill of materials, and I will save it there. And then if I open up my spreadsheet, I have some jumpers that could be combined. So I can consolidate this, but that then gives me the bill of materials to build one of these boards. And then if I'm going to build 20, then I just need to multiply these quantities here by 20 and place an order. So I'm going to work on trying to source all of this. I don't know that I'm going to source it all from the same vendor simply because of pricing. This one's going to get expensive. That said, I think we're done. I'm going to go place that order. Between finishing all the video and the editing, and of course I do my intro and to-dos after I've edited everything, I have been able to find and source all of the components for the PCB, so those have been ordered. So once all those show up, it's going to be a matter of assembling the PCBs. While I'm waiting, I'm going to work on some of these to-dos. I've got some troubleshooting still to do on the clock. I want to get that taken care of. Do want to have a conversation about the opcodes and operations and lay out the design work for that, because that's going to drive a lot of what happens going forward. It's going to open up a lot of doors. Of course, my test harness needs a line driver added to it so that it can not conflict with anything else that might be on the bus. Thank you, and we'll see you soon.